Okay, so I'm just going to show you how to do some soldering. To start off with, I've cut my pipe, 22mm pipe, so you can actually see what I'm doing. I've also got 2 bricks, which is something which I wouldn't normally do, but it just takes the pipe off the bench, so we're not going to burn the bench, right? A little word on heat-proof mats. Firstly, get different types. Okay, so this one here is the same type of material. It's a heat-proof formulation. This one here is quite old. This one here is a brand new one. It's been designed so it can actually go around pipes. Say if you're underneath a radiator and you have to do some soldering or close to the wall. We've also got this one here, which again is a slightly thicker mat. Okay. The main thing is it's a heat-proof mat. It's a piece of health and safety equipment. So you have to make sure that it's in good condition. Okay. And also, so all these strands here, these all here can catch fire. Okay. Also, we can see we've got little holes in the matting itself. So always inspect your mat and make sure that it's in good condition before starting to use it. The other word of advice which I might give is when using a mat, always trying to make sure that the same side is against the wall. If you notice, this one here has been used on both sides, and if I was just to put it against a piece of white paper, you can see that all the soot comes out on the paper itself. Obviously, if you're working in someone's house and they've got freshly painted walls, you don't want that to come through. So just make sure that you can even put an X on it if you wanted to, just so you know that X always goes against the wall and you always do soldering on one side. So, next thing we need to do is just prepare the pipe. So I'm just going to use some wire wool, and what I'm going to do is I'm just going to clean the surface layer of corrosion, known as patina, off the pipe itself, okay? So I'm just going to take my wire wool, be careful with your fingers, make sure you don't get any wire wool in your fingers. If you want to wear gloves, you can. Okay, so I just cleaned off the pipe on both sides. Okay, so what I'm going to do is just use a straight connector just to join in 2 pieces of pipe together, really. Okay. A little word about different types of fitting. This one here, which you can see, this is called end feed, which means you feed the solder into the end of the fitting. You'll notice it's nice and straight and flat, and if you look on the inside, there's nothing on the inside there. Okay, so that's called end feed. We've got the same type of fitting here, so it's a 22 by 22 by 15mm T, but this one here is slightly different. This one here is pre-soldered. So if you look at the little solder rings on the side there, you can see it's got a couple of little lumps, or a little lump on each side, and that there is solder, so it's pre-soldered. And these are called Yorkshire or integral solder ring fittings. Okay, these are more used by DIYers, I suppose. These are a little bit cheaper, these are a little bit more expensive, normally about twice as expensive. So as long as cost isn't really an issue, you can use these. They just don't look quite as nice when you solder them. Okay, so I've prepared my pipe itself. Now what I'm going to do is I'm just going to take the patina off the inside of the fitting. So I'm just going to clean up my fitting. Okay, there you go. I'm going to take a heat-proof mat. I'm just going to place that underneath just to protect the workbench. I'm not going to get any heat anywhere near it, but still, health and safety. Next I'm going to use some flux. Okay, so this is Fry's Power Flow Flux, which in my opinion I've just used it all the way through my plumbing career. It's just a really good flux. The purpose of the flux is to create a capillary effect, to draw the solder inside the fitting. Without flux, the solder will just run off. Okay, so all I'm going to do is take some solder. You can use a flux brush, I just tend to use a little bit of solder. And what I'm going to do is I'm just going to take some flux, I'm going to place it around about 5-7mm around the pipe itself. You always fit it to the male end of the fitting, okay? Just push that in. And again I'm going to do it on the other side. The reason why we apply it to the pipe and not the fitting itself is because some fluxes can be quite aggressive and they can be quite corrosive as well. So normally with plumbing work, water passing through it and disinfecting and cleaning the system out, it wouldn't be an issue. It's going to clean all the pipe work out on the inside. But places where you might need to be very careful is things like gas supply, where you haven't got anything pushing that excess flux out. So by putting it on the outside of the pipe itself, when you fit it together, any excess should be on the outside of the pipework itself. Okay? So I'm just going to prepare my blowtorch. This is a Rothenberger Superfire 2. So it's a really good blowtorch. You can pick them up for about £60, thereabouts. The main parts to it is we've got an adjustable gas on the back here, which controls the amount of gas going into the torch itself. On the side here we've got our on and off button, so I'm going to click it onto on and our piezo lighter. Okay, so all I'm going to do is switch it onto the on position, open up the gas adjuster on the back, and press down. Okay, and I can adjust my flame depending on the amount of heat that I want to go to that fitting. Obviously, with bigger diameter pipes, you're going to need more heat, so you're going to have more gas going to it. And smaller size pipes, we wouldn't. Okay. There's also a little button on the top here, which when I switch it on, I can hold my button in, and now I don't actually have to press at all. In order to switch it off, I can press my button in again. Okay. It's a feature which is on these torches. Personally, I don't like using it. And I certainly don't like students using it either, because what they tend to do is they light it, they might just leave it on a bench and start working, in which case you could obviously knock it off and it could be a fire hazard possibly. All right. So the way I hold the blowtorch is I hold it upside down in my left hand. I'm right-handed, so I need control over the solder in order to do some soldering. So I hold it in my left hand, I rest my thumb on this little ledge so I can control the flame. So what I'm just going to do is hold it underneath, okay? And I've got complete control of that blowtorch at all times. A little word about fluxes, about solder, is you can get different types. This one here is unleaded. You can tell by the green spool on the outside. It's unleaded, so that means you can use it in potable, wholesome water supplies, places where you drink from, okay? That would include the toilet because it's still fed on the same supply. You could use the leaded type, which is indicated by a red spool, on things like gas supply and central heating systems. So that's the sort of two areas where you could use the different types of solder. But personally, I would just use unleaded for everything, because then you're not going to make a mistake. Okay, so I just pull out some solder and I give myself around about 40 ml, just so I know how much solder is actually going to go inside the fitting itself. I've got a little bit of flux left on there as well, and that doesn't make there's no problem at all. The way I hold it is I've got the spool in my hand, and I'm going to use my forefinger here just to be able to control where I'm going to put the solder on the fitting. And that's why I think it's more important to be able to just hold the torch here and have my solder in the right hand, so I can actually put it to whichever side I need to. So I'm just going to take my blowtorch, holding it upside down, as I said, and then I'm going to get the hottest. I'm going to start heating it in the centre here, and I'm going to move to the side which I want to solder first, and then move to the other side, okay? Through conduction, the heat's going to move down each side, so be careful obviously, because it's going to get hot at both sides of this. So I'm just going to heat it up, and what you'll see is you'll start to see the flux melting, okay? I'm not holding it too close, I'm directing the heat away from the bench, okay? So I'm just going to move it to the left-hand side, just going to heat it up nice and gently. On the other side. Okay. What I'm doing is just checking for a solder ring to have gone around each side and all the way around the fitting, which it has. I've used up around about 20 ml, about 10 ml of solder on each side. I'm just going to switch my blowtorch off and turn off the gas and lay that down on the bench. Next thing I'm going to do, give it about 10 seconds for the heat and the solder to take. If you put cold water on it too fast, it's going to crack the solder and it could leak. So give it a couple of seconds really. And what I'm going to do is I've just got a damp rag here, and I'm just going to cool it down. Okay, nice and gently, just going to cool it down. And what I'm doing here is twofold. Firstly, I'm cooling it down. Secondly, I'm removing any flux residue. So I'm just cleaning it all off. Okay, still quite hot. Just cleaned it all off, and just ordinarily I'd probably leave it for a couple of minutes. All right. Remember, you have to do any hot work, any soldering work, at least half an hour before you leave premises, which means that if there was any sparks or anything else, you could deal with it. So I've just wetted it all down, removed any flux residue, and I'm just going to dry it off now. Okay, so as you can see all the way around, I can see that it's got a soldering all the way around there. Got a little bit of a drip there, which isn't really much of a problem. If it was painted, then you're not really going to notice it. The next thing I'm going to do is get some wire wool. Just clean it all up. Okay, and as you can see, that's soldered now, and that's ready to go. We can pressure test it, and I'm pretty confident that's going to hold pressure, test pressure, which is 1.5 times maximum working pressure. Okay, and that's what it needs to look like. It needs to be free from flux. It needs to be buffed up and shined up. Remember, the customer might not know what you're doing, or else they'll do it themselves. But what they are going to do is they're going to go underneath the basin, underneath the bath, and they might have a look at the pipework. And if it looks bad, then it doesn't give a very good impression. But if it looks really neat, if it looks nice, they can see you've done a really good job of it, then obviously they might sort of call you in for extra work. All right? Another thing is, the reason why we remove any flux residue is because this happens. So I found this in the recycling box. See, it all goes green all the way around it, okay? The green is where the flux has just run down and the student or whoever's done this has not wiped it all off. You also notice that what they've done is they've taken the solder and just dabbed it all the way around. You can see that because it hasn't just got 2 marks. You can actually see where they've dabbed it all the way around. It's incorrect, you don't need to do that. You just need to put it onto one spot on each side and allow the flux to do its work, create that capillary effect, draw the solder around and inside the fitting, and then it will just do the job for you. Okay? And that's how you solder.